choose the region. What? I can take it. There is a ton of money left.
I thought it was
You can't.
The money's for the baseball team. It's not like his personal money.
You can't accept it.
Can I have that cash?
Somebody dropped a bunch of it before the cafeteria.
Oh, that's not good.
Okay, so let's talk about some linear transformations of random variables. Now, first semester we talked about linear transformations before. Hopefully this is going to be kind of familiar. Whenever we talk about transforming data, whenever we have all our summary statistics and we take all of the values and we multiply them by something, which measures does multiplication affect? Do you remember this? What did you say? All of them. Very good. So if you're multiplying, it affects everything. When you are adding, it does not affect everything. Which ones are not affected by addition?
Range.
Standard deviation, range. What kinds of measures are those called? What are we measuring with that? Spread. Okay, so any measures of spread are not affected by addition, just multiplication. So that's going to be true here as well. Okay, so those same things still true. So if we're looking at how they are affected by addition and multiplication, when we're talking about the mean or expected value, the new mean. I just totally wrote an M instead of a W. That's just weird. The new mu, I combined new and mu. The new mean is just the multiplication times the old mean plus whatever we're adding. So we get the new one by doing the multiplication and the addition. So we multiply and add for mean or expected value, whichever way they ask you about it. For standard deviation, it's a measure of spread. So for the new sigma, or the new standard deviation, we just do the value that we're multiplying times the old, and that gives us the new. So we multiply only. So don't do the addition on the standard deviation. That's what people miss most of the time, is they will do the addition when they shouldn't. This one, they usually get because you just do what it tells you to do. This one is the one that's usually missed because you forget and do the addition. For variance, find the new standard deviation and square it. This one, variance is not the old variance times the multiplier. Okay, because you multiply it here, then you square it, so it's really times the multiplier squared. But if you found standard deviation, just square it and get variance. It's the easier way. Okay. So, let's go back and look at an example. So here we have Peace Jeep Tours. They offer a popular day trip to a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 people. So we want to find the mean and standard deviation of the number of passengers. Okay. So to find the mean, we just take each value and multiply it by its probability. Who knows? My pen is doing things that I'm not telling it to do. It's one of those times. Okay, so hopefully you remember this. We did a lot of these whenever we were doing that review on Friday. So if you wanted to do this quickly on your calculator, how would you do that? Put this top row in L1, bottom row in L2, and then do one bar stacks. L1, L2. This should give us 3.75 passengers. So on average, they have 3.75 passengers per tour. So to get standard deviation, we need to find the variance, and then we'll take the square root. So for variance, we just take each of these values and subtract the mean, square the difference, multiply by the probability. 2 minus 2.75 squared. And when we did this on the calculator to get this 3.75, when you put that in L1 and L2, and then you do your one bar stats, it's going to give you standard deviation. You're going to look for the sigma x. That's your standard deviation. Your standard deviation would be 1.0897 passengers. Okay, questions up to there. This is kind of what we were doing before. The next part says that Pete charges $200 per passenger. We're going to let C equal the money collected for each randomly selected trip, and we're going to fill this in. So this first one is if there were 2 people on the trip, he had $400. That's $200 per person. If there were 3, it would be $600. 4 would be $800. 5 would be $1,000, and the 6 would be $1,200. Okay. So if you have put this into your calculator, you can always go up here and say, I want to do these numbers times 200. So you can just do L1 times 200. So you can see that's what I'm typing in here. And it will change all of those for you. Which here we have 5 numbers, so it's not that big of a deal. But if it were a really long list, that saves you some time. So then we could go back and do our one bar stats again. And here's our mean and standard deviation for how much money was taken in for each trip. Okay? So when you're doing this, you still have to write out what you were doing. I know. I'm writing it too, so don't complain too much. per trip is $750. And we need to get standard deviation. When you're writing all of this out, I hesitate to give you guys a shortcut. But you are allowed on the AP exam, if you have the first two, you can do this ... and then put the last one, but you have to have at least two and then the last one to show you did this all the way until you got here. So if you don't want to write out all of them, you can do this little ellipses to show you skipped some, but it's all the same thing. Number the calculator got us, I'm going to put over here to the side. So that's standard deviation. And if I don't want to type all of that in, it doesn't tell me variance here. But what I can do, you see this bars button here? When you go to bars, it says statistics. It keeps track of all of those. From the last time you did your one bar stats, everything is stored in here. So I can go to number 4, and I can just say square that value. And that's the value squared. So if you want a precise value without having to type all of that in, you can do that to get to it. So bars, statistics, right underneath the arrows. Right underneath. Okay. We get up to here. Questions? Okay. So this part says it costs Pete $125 to buy permits, gas, and a ferry pass for each trip. Okay. So the amount of profit he makes is just what he took in for what we calculated here minus this $125 that he is having to pay to go on the trip. So we want to take each of these and subtract $125. So what we're going to do, I'm going to go back into the list, and I'm going to go up to the top of L1, and I'm just going to do L1 minus 125. Now those are the amounts of his profit. Okay, so these are the numbers that need to go in that top column, or the top row. Some of these are not correct, so correct the ones that are not on there correctly. So this first one should be 275, not 175. Then we want to count what is our average profit and what is the standard deviation of that. It let you found this part, this, without having to type all those in. You just find this and then square it and see that one. Yeah, This was the standard deviation. And when we use square, we get the variance. No.
Standard deviation from variance to square.
Exactly. So hopefully we're noticing this was our original number of passengers, and if we made $100 or $200 off each passenger, we should get this. So if we took that 3.75 times 200, we should get this number, because the mean is just that number times your multiplier. If we take this number and subtract 125, we get this one, because that's what we did to all our data points, was subtract 125. So this process is really showing you how this works. Okay? Because here we multiplied by something, here we subtracted something. So what do you think our variance and standard deviation are going to be here compared to here? We subtracted 125, so what's that going to do to variance and standard deviation? Does it change them? No, because it only changes when we multiply. So our variance and standard deviation should be the same. So if I do, you notice that standard deviation is exactly the same as what we had up here. Because subtracting doesn't change standard deviation. Okay? So, if I show my work, variance is still 47,500. Standard deviation is still $217. Questions on this? Does it seem okay? It's similar to what we did before, but we're just doing with random variables instead of just summary statistics. Okay, so let's look at the backside. The backside is, some of these will give you data, some of them do not. So this first one says, in a large introductory statistics class, the distribution of raw test scores has a mean of 17.2 and standard deviation of 3.8. The professor decides to curve the scores by multiplying the raw scores by 4 and then adding 10. So what this is saying is he's doing the mu starts off as 17.2, standard deviation is 3.8, and he's wanting to use this 4x plus 10 is our linear transformation of the data. We're just multiplying the scores by 4 and adding 10. Do we understand how I got that from what it said?
Yes.
Okay. So then we want to transform each of these using this information. Now on mean, do I multiply, add, or both? For mean. Do both. Okay? So mean just plugs into that formula. So my new mean is going to be 4 times 17.2 plus 10. And you want to show that step. You want to show what you did to get your new value. So the new mean for this test score is 78.8. Exactly. It's better. Now what about standard deviation? Do I multiply, do I add, or do I do both?
Multiply only.
Multiply only. So for the standard deviation, I'm going to do 4 times 3.8, and that's it. Don't do the addition. be careful. If it's spread, don't add it. Okay, we good on the first one?
Yeah.
The next one says, a small ferry runs every half hour from one side of a large river to the other. Based on historical records, calculations by the ferry owner's cousin, who happens to be an AP stat, the ferry owner can expect 3.87 cars on a typical trip. So that's our mean. With the variance of 1.6531. So I'm going to go ahead and write that down. That's the variance is 1.6531. And a standard deviation of 1.286. So part A says the cost for the ferry trip is $5 per car based on your answers, or based on the info above. How much money can the ferry owner expect to collect on a typical trip? With what variance and standard deviation? So this is saying the cost is $5 per car. So we're looking at 5x. So however many cars we multiply it by 5, that's how much it's costing. Okay. So when we're doing multiplication, do we multiply the mean, the standard deviation, or both? Both. So I'm just going to multiply both of these by 5. So for the mean, it's just 5 times the 3.875, or 3.87. And then the standard deviation would be 5 times 1.286. Because it's just 5 times the car. There's no addition on this part. There's our mean and standard deviation. How do I get variance?
Square the new standard deviation.
Exactly. So the variance is just going to be 6.43 squared. So I take whatever my new standard deviation is and I square it. That's my new variance. Notice if I just multiplied the original variance by 5, I'm not going to get this. So don't just go through and multiply everything by 5. You have to be careful. Find your mean and standard deviation and then square standard deviation to get variance. Are we good on part A? Part B says the ferry company's expenses are $20 per trip. In order to find the profit on a typical trip, we take the amount collected, which is what we found up here, minus the expenses, which is $20. So based on your answer from part B, gosh, I proofread very well. What do you expect the company's profit to be with what variance and what standard deviation? So we're doing the this minus 20. So if we're subtracting 20, which of these three measures are affected by subtraction? Just the mean. Does that make sense? Because these are measures of spread, subtraction has no effect. So this one, the mean, is going to be $19.35 minus 20. They're going to not be doing good here. Losing money. So they're losing 65 cents on average for each trip. Mean and standard deviation, or the standard deviation and variance do not change. So my new standard deviation is still $6.43, and my variance is still $41.3449. Are we okay with that? Because this sometimes can look confusing.
What?
Did you not learn anything about your time over there?
I learned some things, but
Learn to get off your phone.
we're not learning anything right now. I've already written everything I should down.
Still, just pay attention. Okay, here we go. Number 3. Yeah, at least pretend. Okay, so we're looking at broader partners. Planning a new investment. So we want to look at the amount and then the probability. So how much are they going to make off an investment? So this is expected profit in millions of dollars. We want to find the expected profit and the standard deviation. So for the expected profit, we're just going to do our multiplication and add. Everyone's going to make profit. Yeah. And there's no negatives, so you didn't lose money on anything, so that's nice. So $3 million is the average profit. Pretty nice. Pretty nice.
No, you wouldn't. You would not.
So this is not a question on here, but does it make sense for the standard deviation to be almost as much as the mean? What do we notice about the potential profits? They range from 1 million to 10 million. So 3 million is kind of on the lower end of between 1 and 10, right? So if you're looking at the difference between 3 million and 1 million, that's not that big. But between 3 million and 10 million, there's a lot of difference. Okay, if you're expecting 10 million and you only get 3, you're not going to be happy. So there's a big difference here, which is why this is kind of a large number.
So it'll be all right.
Does that make sense to you? If all the numbers were pretty close to 3 million, we would have a smaller standard deviation. Okay. So, part B. These people owe a leader fee of $200,000 plus 10% of the profits, we'll call the profit X, to this be? This is our equation that we're going to use for our linear transformation. Okay? So they want us to find the new mean, the new standard deviation of how much profit they will make. So this equation tells us about profit. So, hang on guys. If we're finding the mean is affected by multiplication and addition or subtraction. So we're going to just plug this 3 right into here to get our new mean. Notice since we're talking about money in millions, this 200,000 became 0.2 million. Okay, so that's why the 0.2. So when the average investment earns 3 million, the actual profit is 2.5 million. For standard deviation, I'm going to plug in this number to the formula, but which part do I not do? The subtraction. I do the multiplication only. So there's my mean and my standard deviation for the profit made on the investments. Okay, so this notes page is going to page 20. Page 21 is problem set number 40. So it's going to look just like these two on the back side. So make sure it's done for block day. What else are we doing on block day? Notebook check. Make sure you're ready. Notebook check. So make sure all your problem sets, all your note papers, everything's attached and finished.
One's a race, or two is racing, yeah, he actually shows up.
What's our answer?
Yeah.
Just a second.